Hello, good day viewers. Welcome to another mathematics presentation. So here I want us to go through mathematics paper 1 for 2019 external candidates. So we'll be doing some random questions. So I have question 1 right here. Simplify 4 minus 2 in brackets we have b minus a cross bracket minus 1. So they want us to simplify this expression. So under our step 1, we are going to write the expression which is 4 minus 2 open bracket b minus a cross minus 1. So to simplify means to make this expression simple, okay, or to write it in a simple form. So first thing, we can see that we've got brackets here. So we are going to open these brackets by multiplying with a negative 2 right here. So negative 2 times b, you have negative 2b. The negative 2 times negative a, you have positive 2a. So that means you have open the brackets. So we are going to write 4. We have said this negative 2 multiply the b. So we are going to have negative 2b. Again, this negative 2 multiply negative a. We are going to have positive 2a. Then minus 1. Now from there, you can see we have 4 minus 2b plus 2a minus 1. We need to collect the like terms. So 4 and the minus 1 are the like terms because they don't have any variable. So we are going to write 4 minus 1. Then we can say plus 2a minus 2b. So for these two, for 2a and 2b, they are not the like terms because this one is having the variable a, this one is having the variable b. So these are unlike terms. So just simplify 4 minus 1. So this minus 1, it was a minus 1. Just move it with the sign that it has. You take it to 4 right here. No need of changing the sign. So from there, we are now going to say 4 minus 1 to give us is 3 plus 2a minus 2b. So this is our answer. Alright guys, so we've now come to our question 2 right here. Evaluate. In brackets we have the fourth root of 81 cross bracket raised to the power of a 3. So our first thing, we are going to write the question, which is the fourth root of 81 in brackets, then raised to the power of a 3. Okay, so now fourth root means a number that you can multiply by itself 4 times to get that particular number. So here we have 81. So the fourth root of 81, meaning that the number that you can multiply by itself 4 times. So if we say 3 times 3 times 3 times 3. So 1, 1, 2, 3, 4. So when you multiply these two, and when you multiply these two, so 3 times 3, this one to give us 9, times, again this 3 times 3 also give us 9. So 9 times 9 will give us 81. So the fourth root, okay, so the fourth root of 81, it's a 3. In brackets, remember there is a power which is right here, so you need to raise it to the power. So this means that 3 to the power 3. It means we multiply the base 3 by itself 3 times, which is 3 times 3 times 3. So this will give us, when you multiply these two, you'll get a 27, you get a 9, then times a 3. So we get now a 27. So 3 times 3, it's 9. 9 times 3, 27. So this is our answer. So I hope that you are following. Alright guys, so we've come to our question 3 right here. Factorize completely 32x squared minus 50. So they want us to factorize completely. So first thing, let us write our expression. We have 32x squared minus a 50. Okay, so from here we need to factor out what is common. So in terms of the letters, we only have x. Here there is no letter. Then we have 32 and a 50. So the highest common factor of 32 and a 50, it's a 2. So it means that we are going to factor out a 2. Now to know what numbers we are going to write inside, so we are doing this 32 divided by the number that we have factored out. So when you divide 2 here 1, 2 into 3 it's a 1, remainder 1, 2 into 12 it's a 6. Okay, so we are going to remain with a 16x raised to the power of 2 minus, we also do the same, okay, where we have a 50 divided by 2. So 2 here 1, 2 into 50 it's a 25. So it means that here we are going to write a 25. So this is very important. Okay, this is very important so that you know what you are doing. So this is what we have. We have 2 outside, inside we have 16x squared minus 25. So you can see 16 is a perfect square number. 25 is also a perfect square number. So this x is already squared and there is a minus here. So let us try to square these perfect square numbers so that we come up with a difference of 2 squares. So we are going to have 2 open bracket. So this will be 4 to the power 2 x to the power 2 minus 5 to the power 2. Okay, so 4 to the power 2 is the same as 16 because 4 times 4 to give you 16. Then 5 to the power 2 is the same as 25 because 5 times 5 to give us 25. So the reason why I'm writing them like this, so that we see the difference of 2 squares. Here we have a difference which is a minus and the squares. So what we are going to do now is we are going to write our final answer, which is going to look like this. We write 2 open square bracket, then we say I'll pick a 4 and x, okay, minus, here I'll just pick a 5, I cross, again open bracket, again I'll pick a 4 and x, then plus, because I've used the minus, then 5, I cross, then cross square bracket. So this is our answer. We have factorized completely. Alright, so we now come to our question 4 right here. So our question 4 reads, find the gradient of a line which passes through negative 5, 3 and negative 4, 1. So in order for us to find the gradient, we need to take note of the points that we have. So we have been given the points negative 5, 3. Then we also have negative 4, 1. These are the points. So after that, we need to rename our points. So this is going to be x1 and this is going to be y1. Then this is going to be x2 and this is going to be our y2. This one is going to be our y2. So the formula for finding the gradient is m equal to, so we will write y2 minus y1 over x2 minus x1. So from here, we are just going to substitute. Where there is y2, we are going to put a 1. Where there is y1, we are going to put a 3. M equal to our y2, it's a 1, minus our y1, it's a 3, over our x2 is a negative 4, minus our x1, it's a negative 5. We put it in bracket because of the negative sign. So from here, we are going to continue from here where we say m equal to, so 1 minus 3, this is a negative 3, over, so here you can see that we have negative 4 minus negative 5. So first thing, we need to open the brackets. So just write negative 4. So here we are going to multiply this negative times this negative, which will be a positive. So here we are going to have positive 5. Now from here we say m is equal to negative 2 over negative 4 plus 5. It will give us a positive 1. So therefore the final value of m is equal to negative 2. So gradient is equal to negative 2 because 1 into negative 2 to give us negative 2. Alright, so we come to our question 5. The Venn diagram below shows 3 sets: set A, set B, and set C. So we have set A right here, we also have set B right here, and we have set C. Use set notation to describe the shaded region. So they want us to use set notation to describe this shaded region right here, which is in set C. So we can say that A and B, these two sets are shaded, meaning that they were the elements were combined and they had to find the complement of these two sets. So that's why this set C only was shaded. So set notation, we are going to say A union B in brackets, then we put complement. A union B complement intersection C. So this is our answer. This is how we can write set C in set notation. Alright, so we now come to our question 6 right here. The vector PQ is equal to this, negative 3, 2. So this is a column vector. Given that the point P is 1, 4. Find the coordinates of the point Q. So how can we find the coordinates of the point Q? Okay, so to find the coordinates of the point Q, we are going to assume that if you have a triangle like this, okay, so this is a triangle. So in this triangle we have the point. First we have the origin here, then we have the point P, and we have the point Q. So from the origin going to Q, again from the origin going origin to P, origin to Q. So OP, okay, so we have 1, 4. Okay, so PQ, they have given us that we have this column vector which is negative 3 and a 2. So they want us to find the coordinates of what? Q. So how can we find the coordinates of Q? So first thing, we are going to find the column vector of Q, which is OQ. So if we say PQ equal to, so what you are going to do is, if you are moving PQ, okay, if you want to move from P to Q, you say PO plus OQ. Okay, so that is how you can move. So PQ is equal to PO plus OQ. Now when you look at PO, it's against the direction. Okay, it was OP, now it's PO against the direction, meaning that we are going to multiply this vector with a negative. Okay, so this is going to be written as, we write PQ, we have the column vector which is negative 2, negative 3 and a 2, equal to PO will be negative 1 and negative 4 because it's against the direction, then plus OQ. Okay, OQ, you just write OQ because it's what you want, you don't have. So what you are going to do is this, we are going to say, alright, so we are now going to take this column vector to the other side, so remain with this. So we are going to have something like this. We are going to have OQ vector is equal to, so this is negative 3, 2, okay, negative 3, 2, then minus negative 1, negative 4, like this. So once we do our normal subtraction, this will give us the answer which will look like this. So we have OQ vector equal to, so negative 3, we are going to have negative 3 minus, so meaning negative negative is positive 1. Okay, then 2 minus 2, negative negative, positive 4. So the answer will be negative 2, then 2 plus 4, it's a 6. This will be the vector for OQ. Okay, so this is how we can answer these questions. So I believe we can end here. So thank you so much for having time to view this content. This has been your presenter, Mr. Mlenga. Bye bye.